So in part A of this plant growth and response, we ended talking about shrubs and trees. So this is just a quick review that a lot of the growth points in our trees are actually going to be very protected from a lot of the tree structure. So with pine trees, the meristem or the growth point is actually going to be very protected by the needles. And so this actually becomes very, very important from a response to some sort of natural disaster perspective, because a lot of our shrubs and trees may have basal buds, and those basal buds are going to be very close to the soil, so they may actually have the ability to resprout from that disturbance, such as a fire. So this is something that becomes very, very important with how fast or the successive process will be after a natural disturbance. So some of the other adaptations that shrubs and trees have evolved with to help them combat major natural disasters such as fire is bark. So a lot of trees have developed very, very thick carbonous bark that serves as an insulator. So as a wildfire goes through, if the wildfire is actually moving very, very fast, even though it's hot, a tree can actually withstand that and survive that fire because it's not going to be subjected to intense heat and burning for an extended period of time. So my brother-in-law, he's a dozer operator for Forest Service, and he deals with this aspect all the time. And he says in his observations, as long as a tree hasn't been burned up past the halfway point, chances are it has the ability to survive a fire. So, however, if you get a very, very hot fire that is moving somewhat slowly, it's kind of relative, you can actually damage those trees very, very easily. So also another adaptation that pine trees have developed is in their cones. So the serratinous cones that you'll actually see in those on those type of trees, once they are heated up with the heat from a fire, they will actually open up and disperse the seeds into the soil, enabling that tree to come back at a later date. So it's kind of a precautionary mechanism that the trees have developed. All right, so our second major thing that we're talking about is the location of the growing points relative to rangeland plants. So again, with each type of plant and each species within that type or category, the location of the growing points are going to be very different. Some of them may be basal, where the meristems are down towards the soil. Some of them may be actually elevated, like we see in a lot of our shrubs and mesquite. So in that, from a grazing standpoint, can actually be very good. It's the ones that are in the middle that we have issues with. So if the growth points are near the soil, chances are a lot of animals are not going to spend a lot of time consuming one whole plant. They're going to take a bite of the top of the plant and then move on. However, if you're heavily stocked, like heavier than you need to be, then a lot of times, even though the first grazing bout, the animal will take the top part of the plant. If you have a lot of animals in that area, a second animal may come around and take the bottom of that plant and expose those growing points, or even take their growing points if they're at the basal level. An example with our shrubs is if the growing points are actually really high and the plant has quite a bit of elevation to it, then unless they're giraffes, they really can't get to them. So those growing points are going to be very protected. However, if they're low, within grazing distance at all, they can actually be grazed, probably preferably, because that new material, especially in the spring, is very proteinous and very, very sweet. So a lot of those animals like that extra protein. So you just have to be aware of that and not overgraze certain areas. So growing points is also going to depend on the season. With our grasses, just thinking about right now, we've been very lucky to get some October and November rain, and there's actually grass in the valley, and we're at the first part of December. But the growing points on those grasses are very, very low near the soil because the grasses themselves are not very tall yet. However, in April, the grass would be near the end of its maturation phase, be seeding out and getting ready to end its life cycle if it's an annual plant. Therefore, those growing points are going to be pretty high. So keep in mind, if you're early in the growing season, the growing points are going to be closer to the ground versus when you're in the end of the growing season. So a few factors that limit plant growth are heat, the root system, as well as their shoot system above ground. So heat really has to do with the optimal temperature. This relates back to our C3 and C4 plants. So our C4 plants really don't do well less than 82 degrees. However, our C3 plants really don't do well unless it's less than 72 degrees either. So cool season versus warm season plants. And then the root system has the ability to limit plant growth because of the availability of water as well as nutrients and nitrogen. So if there's an abundance of roots, but there's not an abundance of minerals and water, then that plant is going to be severely limited. And then above ground structures such as the rhizomatic or the reproductive system, the tillers that are going to be across the ground, the shoots, those actually have the ability to be photosynthetic as well. So they have the ability to gather light, go through the photosynthesis process. So depending on how mature those runners are, they actually may complement or limit plant growth, depending on where the meristem is at and how much photosynthetic capacity that plant has. So just another note about how the plant is going to respond to a grazing bout really has to do with their resources. So plants have the ability to allocate their resources. So this is what we call phytosynthate, and this is where the priority of the plant is going to shift towards acquiring the most limited resource. So if the water is limited, such as in a drought year, then allocation of the plant is going to switch from photosynthesis to conservation mode, where it's actually going to concentrate on growing roots rather than growing shoots or above ground material. And then leaf area is also a major limiting factor as well. So if leaf area is limited because of a heavy grazing bout or a mowing activity, then the allocation is going to move for leaf growth over shoot growth. And so the plant won't worry about underground materials too much because it needs to add more leaf material for photosynthesis to take place. So just a few of the main concepts that we've talked about in this lecture, part A and part B, is when it comes to how a plant is going to respond to a grazing bout, really also has to do with nutrients available, so nitrogen uptake. So nitrogen is only going to be taken up in the plant as long as there is water. If water is limited, then the nitrogen fixating ability of that plant will be limited. So there's going to be higher levels of available nitrates and nitrogen, and if the water is efficient. So this is where the whole concept of irrigating on rangeland really starts to lose steam, other than it's expensive and who would want to do that. But because we have to depend on Mother Nature for precipitation, it's not a dependable source. Therefore, rangelands, it doesn't do any good to put on nitrogen-based fertilizer because you are not necessarily going to get rain. So, and then a lot of the available nitrous oxide in the soil is actually going to affect the species composition of the vegetation. So if it's a weed, the weeds actually require much higher levels of NO3 than the climax grasses. So it's really inefficient from a soil perspective to let invasive species get out of control because they require higher levels of nitrate oxide. So again, this is not the first time that you guys have seen this figure, but just to revisit the concept of the removing the leaves really does affect the roots. So in a classic example from the 1950s, this is where the take half, leave half scenario was developed from. So if we have a plant that has not been grazed at all or clipped at all over here, and then we've got one that is missing 50% of its mass, one that's missing 70%, and one that's missing 90% of its mass, and you can see that it affects the roots as well. So the whole concept of take half, leave half really came from this concept of removing 50% of the plant material because you're not going to see a big decrease in root mass. Whereas at 70% you see a huge decrease, and at 90% there's almost no roots there at all. So root growth is really going to decrease proportionally as defoliation removes greater than 50% of the leaf area. So again, the take half, leave half scenario. And then also one thing to keep in mind is the frequency of defoliation. So how often a plant is grazed repeatedly. And that intensity really determines the total effect of defoliation on the root growth. So the more intense the defoliation event, the greater the effective frequency of defoliation will be. So some of the consequences of reduced plant growth or reduced root growth, is you're going to see a decrease in the absorptive area of the roots. So that means that there's less area to take in minerals and water, etc. And then the soil volume for those resources are going to be affected as well. So if you are constantly grazing and you don't have near the root mass that you need to underneath that soil layer, then chances are a lot of the water and the nitrogen is not going to be used there either. And so just think about that in terms of competitive interactions. How do we manage that relationship? And one example is actually with forests. So each individual tree uses a lot of water. So upwards of like 200 gallons of water a week in some areas. So that would be a lot of water that could actually not be used and run off into reservoir systems, rivers, and lakes. So there is a concept out there, and it's actually creating or making more headway, but to more effectively manage the forests in times of drought, so that those trees aren't using up all that water that could actually go into a reservoir system. All right, and then last but not least is carbohydrates. We've talked about structural versus non-structural carbohydrates, and so this really has to do with the photosynthetic process and the ability for a plant to grow new shoots. So reserves of carbohydrates are going to exist, and they provide a small amount of energy to contribute to leaf growth after a severe defoliation event. And that could be a spring freeze or a fire or intense grazing or whatever. So leaf damage is leaf damage. So the growth of a plant is going to be very exponential depending on the rate of plant growth at any point in time. So the total amount of the root and the shoot biomass is going to be more important than the concentration of reserve carbohydrates. So it's more important to focus on the roots and the shoot biomass that a plant has rather than where the carbohydrates are